Some supermassive black holes launch powerful beams of material, or jets, away from them, while others do not. Astronomers may now have identified why. Using data from NASA's Chandra X-ray Observatory and several other telescopes, researchers have studied more than 700 quasars, rapidly growing supermassive black holes, to isolate the factors that determine why these black holes launch jets. Jets from supermassive black holes can inject huge amounts of energy into their surroundings and strongly influence the evolution of their environments. Previously, scientists realized that a supermassive black hole needs to be spinning rapidly to drive strong jets. But not all rapidly spinning black holes have jets. In a new study, a team of astronomers discovered another determining factor of whether a supermassive black hole has jets, something called a black hole corona, threaded by magnetic fields. In astronomy, the term corona is commonly associated with the outer atmosphere of the Sun. Black hole coronas, on the other hand, are regions of diffuse hot gas that lie above and below a much denser disk of material swirling around the gravitational sinkhole. Like the corona around the Sun, black hole coronas are threaded with strong magnetic fields. The new study suggests that a quasar must have a bright black hole corona, threaded by strong magnetic fields, in addition to a rapidly spinning black hole, to produce powerful jets. Quasars with fainter black hole coronas and weaker magnetic fields have less powerful or non-existent jets, whether or not their supermassive black holes are spinning quickly. The new study draws parallels between these giant black holes and those that weigh less than 100 times the mass of the Sun when it comes to their ability to generate jets.